Alright, welcome back. This is our last lesson on infinite geometric series, but before we dive right back into this topic, I want to show you something very important. Okay, I told you guys to use a trick, but I'm going to show you when this trick works and when this trick does not work. 5 times quantity 2 to the k minus 1 power. Okay, let's first start by calculating our values. So we're going to put in 1 for k, 2 for k, 3 for k, 4 for k, and 5 for k. Alright, so we're going to start with 1. 5 times 2, and if we put in 1 for k, 1 minus 1 is 0, so we get 0. Okay, 5 times 2, we're putting in 2 for k. 2 for k goes in, 2 minus 1 is 1. Okay, 5 times 2, we're putting in 3 for k. 3 minus 1 is 2, so we get 5 times 2. 3 minus 1 is 2, so we get 5 times 2 to the second power. We're putting in 4 for k. Okay, 4 for k gives 4 minus 1, which will be third power. 5 times 2 to the third. And you should be very comfortable with this based on previous videos. So make sure you watch the previous first, always. Okay, putting in 5 for k. 5 minus 1 is 4, so we get 5 times 2 to the fourth. Now, okay, so let's calculate each one of these. 2 to the 0, we start with our exponent. Okay, reminding you 7 to the 0 is 1. 8 to the 0 power is 1. 152.3 to the 0 power is 1. Any number to the 0 power is 1 except for what? 0 to the 0 power is indeterminate. Very important for what's coming. Okay, so 0 to the 0th power is indeterminate. Okay, so we're looking at 7 to the 0, 8 to the 0, 152.3 to the 0. Any number to the 0 power is 1 except for 0 itself. Make sure you know this. 2 to the 0 is 1, so we get 5 times 1, which is 5. 2 to the first is what? 2. So we get 5 times 2, which is 10. 2 squared is 4. 2 squared means what? 2 times 2, okay, which is 4. So we get 5 times 4, which is what? 20. Okay. 2 to the third means what? 2 times 2 times 2. 2 times itself 3 times. Remember, 2 to the third is not 6. It means 2 times 2 times 2, which is what? 4 times 2 is 8. So we get 5 times 8, which is 40. And 2 to the fourth is what? 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Faster way to do this is pair them up. 2 times 2 is 4, 2 times 2 is 4, multiply 4 by 4, get 16. So we get 5 times 16, 5 times 16, which is 80. Okay, so these are our values. And remember, sigma means add them up. So we're going to write, add them up, 5 plus 10 plus 20 plus 40 plus 80 equals what? 155. So you just add them up. Now, I told you guys, I'm going to erase this for a minute. I told you guys there's a little trick here. Watch this. The trick was, instead of calculating our values, we say that 5 is what? 5 is a sub 1, and 2 is our R value, what we're multiplying by. So our first value is 5. That matches up. And we're multiplying by what? We're multiplying by 2, so we multiply by 2 to get the next value. 5 times 2 is 10. Multiply by 2 again. Remember, we're multiplying by R. 10 times 2 is 20. Multiply by 2 again. 20 times 2 is 40. Multiply by 2 again. We get 40 times 2 is 80. We add them up. Okay, add these up. We get what? 155. Now, I want you guys to work this problem. Okay, in your notes, see what this gives. All right, we're looking at sigma k equals 1 to 5 of 4 times 2 to the k power. Okay, a little different. I want you guys to use the trick. Use the trick. Okay, so 4. Circle 4. 4 is what? A sub 1. Circle 2. 2 is what? R. Okay, so our first value is what? 4. And we're multiplying by what? We're multiplying by 2. So 4 times 2 is what? 4 times 2 is 8. Times 2 again gives 16. Times 2 again gives 32. Times 2 again gives 64. We're multiplying by our R value 2. Okay, 4 is our first. Times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. And we put what? Sigma means add. You get 96, 10, 112, 124. 124, and this is completely wrong. Wrong. This is completely wrong. Why is it wrong? Well, let me show you. Let's see what happens here. I'm going to rewrite the problem. Sigma k equals 1 to 5 of 4 times 2 to the k power. Okay, why is this wrong? The trick does not work here. Notice, let's plug in the values of k. So we get 4 times 2. 4 times 2, what's going in for k? What's going in for k first? 1. then we're putting in 2, then we're putting in 3, then we're putting in 4, then we're putting in 5. So we get 4 times 2 to the first, 4 times 2 to the what? Putting in 2 for k, we get 4 times 2 squared. Then we get 4 times 2, we're putting in 3 for k, we get 4 times 2 to the third. Then 4 times 2 to the what? Putting in 4 for k, 4 times 2 to the fourth. Putting in 5 for k, 4 times 2 to the fifth. Okay, we've already done 2 to the first. 2 to the first is 2 times 4. So we get 4 times 2, which is what? 8. Next, we get 2 squared. 2 squared is 4, so we get 4 times 4, which is what? 16. 2 cubed, we've already established over there. 2 to the third power is 8, so we get 4 times 8, which is 32. And 2 to the fourth power, we've already established over there. 2 to the fourth is 16, so we get 4 times 16, which is 64. 2 to the fifth power is 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. So 4 times 4 is 16, times another 2 is 32. So we get what? 4 times 32, which is 128. Now let's write the sum. Let's write the sum. So our values are actually 8 plus what? 16 plus 32 plus 64 plus 128. Notice. What is wrong with what's up top? Notice, we said up top that 4 was our first value. This is completely wrong. Is 4 the first value? No. Look down here. These are exactly the same problem. What is actually the first value? The first value is 8, not 4. So does this trick always work, that 4 is our first value, a sub 1? No. But I'm going to show you when does it work, when does it not work. We have to know this. Okay, so notice up here, 5 is the first value. Okay, 5 was our first value. Why was it our first value? Because notice, what was our first exponent? First exponent was 0. I want you to notice over here, what was our first exponent? First exponent was 1. Okay, so why was 4 not the first value? Because our first exponent was not a 0. What happens when we take something to the 0 power? For instance, 2 to the 0, we get 1. So if our first exponent is 0, look up here. If the first exponent is 0, putting in 1, we got 1 minus 1 is 0. We end up with 2 to the 0 power, which is just 1. And 1 times the front number is the same as the front number. So 2 to the 0 power is 1. 1 times 5 gives the front number 5. So this matches. So when will this a sub 1 value match? This a sub 1 value will match when the first exponent is what? Is 0. Okay, so the question is, why did it not match over here? Because our first exponent was not 0. You can see this. K equals 1. So we put in 1 for k. The first exponent is 1, resulting in 2 to the first, which is 2, times 4 gives us a first value of 8. So I tell students to do this. Well, you can look at the 0. That's one way to do it. Or you can always just calculate your first value. So I'm going to show you now, erasing this. So let's pay attention to two things. First, I want to know what the first exponent is. Okay, so sigma k equals 1 to 5 of 4 times, let's do this, 3 times negative 2 to the k minus 1 power. Now, it has nothing to do with the k minus 1 versus the k. I'm sorry, k power. K versus k minus 1. That's not the difference. The difference is what's the first exponent. Okay, so if we put in 1 for k. If we put in 1 for k, what do we end up with? I always tell students this. Calculate your first value, right? 3 times 2, put in 1 for k, what do you get? You get 1 minus 1, which is what? 0. Is our first exponent 0? Yes. What is negative 2 to the 0 power? This is 1, resulting in what? 3 times 1, which is 3. Does our front value match? Is our first value going to match the first value? Yes. So what is our first value here? You know that it's what? 3. Now just use your R value to get the rest of your numbers. So multiply by negative 2. 3 times negative 2 is negative 6. Multiply by negative 2, we get what? Positive 12. Multiply by negative 2, we get negative 24. Multiply by negative 2, we get positive 48. We add these up. And again, 5 terms from 1 to 5 is 1, 2, 3, 4, 5. Now I tell students, add the positive numbers first. 48 plus 12 is 60, plus 3 is 63. Negative 6 and negative 24. Now add your negatives. Okay, cross your positive numbers out. 48 plus 12 plus 3 gives 63. Now add your negatives. Negative 6 plus negative 24 is negative 30. 63 minus 30 is 33. Okay? So we see that the front number matches y because the exponent is what? The first exponent is 0. Look at this. Sigma k equals 0 to, say, 4, or let's do 0 to 5. 0 to 5 of, let's do 3, and let's do 5 here. How about, well, yeah, let's do 5 times 2 to the k power. That's fine. I'm just trying to, okay, so we're looking at find the first value. Find the first value. We're plugging in what for k? We're plugging in, be careful, the first value is 0, so we're plugging in 0 for k. Question, will the front value match? Yes, the front value will match. Why? Because the first exponent will be what? First exponent will be 0. So we're going to get 5 times 2 to the what? 5 times 2 to the 0 goes in for k. 5 times 2 to the 0, 2 to the 0 is 1. 5 times 1 is what? 5 times 1 is 5. So does our front value match? Is 5 a sub 1? Yes, it is. So we have what? 5. And now take the 2 and multiply to get your next number. So our value is 2. Now, once you find that your first number matches or does not match, but find your first value, whether it matches or it does not match, you can use your common ratio to get the rest of them. So multiply by 2, so we get what? 10. Multiply by 2, we get 20. Multiply by 2, we get 40. Multiply by 2, we get 80. Hold on. To 5. 1, 2, 3, 4, 5. Do we have all of our terms? No, we don't have all of our terms. How many numbers are there from 1 to 5? There are how many? There are 5. How many numbers are there from 0 to 5? There are 6. 1, 2, 3, 4, 5. Multiply by 2 again, we get 160. And what does sigma mean? Sigma means what? Add. So put addition. And let's look. What is the first value? The first value is a sub 0. Then we have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. How many numbers are there from 0 to 5? There are 1, 2, 3, 4, 5, 6. Okay, so make sure that you have them all listed. Be careful. Now, add them up. 160 plus 40 is 280, 315. So we get 315. You can just add these up very quickly. There is no trick here. 200, 315. Now, looking at this problem, I always say, find the first value. Find the first value. Sometimes it matches, sometimes it doesn't. The more you practice, the more you're going to know when it matches, when it doesn't. Again, you can just look at that front exponent. Let's look at n equals. N equals 1 to 4 of 5. Let's do 3 times, let's do 4 times 1/2 to the nth power. So the question is, will the first exponent be 0? No, the first exponent will not be 0. Again, calculate your first value. 4 times 1/2, what's going in for n? 1 is going in for n. So we get a first value, or first exponent of 1. 1/2 to the first power is 1/2, so we get 4 times 1/2. At this point, you should be very good with fractions. We divide first. 4 divided by 2 is 2 times 1 is what? 2. So we get a first value of what? 2. The first value does not match the 4. Is 4 the a sub 1 value? No, it is not. Now, first value is 2. What do we multiply by? Once you find your first value, whether it matches or it doesn't, just use your r value to find more. So we're multiplying by what? We're multiplying by 1/2 to get more values. So 2 times 1/2. 2 times 1/2 again. 2 divided by 2 is 1 times 1 is 1. Times 1/2 again. Times 1/2. 1 times 1/2 is 1/2. Times 1/2 again. 1/2 times 1/2 gets easy. 1/2 times 1/2. Top times top. Bottom times bottom gives a 4th. 1 times 1 is 1. 2 times 2 is 4. Now, be careful. How many numbers are there? 1 to what? 4. How many numbers is that? That's 4. A sub 1, A sub 2, A sub 3, A sub 4. You can put these under here to help, and then just add them up. So we're looking at what? We're looking at add the fractions first. When we add fractions, we need what? Something must match. When we add something must match, what matches doesn't change. What has to match? The denominator. So we're going to make one of these denominators larger by multiplying. So we're going to make not the 4 larger, but the 2 larger. We're going to multiply by what? 2 and 2. 2 times 1 is what? 2. 2 times 2 is 4, so we get 2/4 plus 1/4. And when we add, something must match, and what matches doesn't change. So we have a denominator, matching denominator of 4, add the top. 2 plus 1 is 3, so we get 3/4. What's in the box is 3/4. Add the numbers, you get 2 plus 1 is 3, plus 3/4, and this final answer is what? 3 plus 3/4 is 3 and 3/4. Okay? Now, with this said, hopefully you don't just take for granted that this is always a matching number, but you understand that it only matches when the exponent is what? The first exponent is 0. And also, I recommend that you always double check and calculate your first value just to make sure that you don't make a mistake. Then use your R value to find more numbers. Then add them up. Okay? So hopefully that clears up some of that confusion. Also, we're looking at, well, today's topic, quickly, infinite geometric series. Now, sigma notation is what we looked at yesterday. Question. Sigma, k equals 1 to now what? Infinity. This means not 5 terms, not 6 terms, but how many terms? Infinitely many. We're looking for whether it's convergent or divergent. So we're looking at 4. Here, let's do this. 8 times 1/2 to the what? K minus 1. My question is here, will the front number match? Will the front number match? Hopefully you say, well, the first value that we're putting in for k is 1. 1 minus 1 gives the first exponent of 0. So yes, the front number will match. 8 will match. If you're not sure, write it out. 8 times 1/2, 1's going in for k. 1 minus 1 is what? 0. 1/2 to the 0 is 1. We get 8 times 1, which is what? 8. Yes, the front number matches. Why does the front number match? Call this a sub 1. Why does the front number match? Because the first exponent is 0 if we put in the k value. Put in 1. 1 minus 1 is the first exponent of 0. Front number matches, we get what? 8. And now multiply by what? Multiply by 1/2. 8 times 1/2 is 4, times 1/2 is 2, times 1/2 is 1, times 1/2 is 1/2, put plus, 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 dot, dot, dot. Why the dot, dot, dot? Because we are adding forever. Again, you have to establish whether this series is convergent or divergent. It is convergent if the R value is what? Less than 1. So we say the absolute value of 1/2 is what? Less than 1. Is this true? Yes, meaning that the series is what? Convergent. And what does the series converge to? The series converges to the formula. And what was the formula? The formula is equal to what? Or this series, if we add forever, gets very close to a specific value. And how do we find that value? With this formula. The formula is a sub 1 over 1 minus r. And so this will find, if we add forever, what this is getting very close to. Again, what is our a sub 1 value? The a sub 1 value is this first number, 8. Okay, so we say that this formula is what? 8 over 1 minus the r value. And our r value is what? R value is 1/2. It's the value that sits underneath the exponent. So 1 minus 1/2. What form of 1 do we want? We want 2 over 2 because we want a common denominator. And so we end up with what? 8 over 2 over 2 minus 1 over 2 is 1 over 2. Okay, remember the denominator does not change. Subtract the top. 2 minus 1 is 1. 8 divided by 1/2 is the same as 8 multiplied by what? 8 multiplied by the reciprocal of 1/2, which is 2. 8 times 2 is what? 16. So if we add forever, what is this going to get very close to? It's going to get forever close to 16. We say that the series converges or gets very close to 16. Forever close. Now look at this. Sigma k equals 1 to infinity of 5 times 2 to the k minus 1. Question, will the front value match? Will 5 be the a sub 1 value? Yes. Why is it the a sub 1 value? Because if we put 1 in for k, 1 minus 1 gives what? 0. So we get a first exponent of 0. Again, if you're not sure, write it out. 5 times 2, putting in 1 for k, 1 minus 1 is what? 1 minus 1 is 0. So we get a first exponent of 0. 2 to the 0 is 1. We end up with 5 times 1, which is what? 5. So our first value is 5. Use your R value. Your R value is 2 to get your next numbers. So we're multiplying by 2. 5 times 2 is 10. Times 2 is 20. Times 2 is what? 40. We put addition, addition, addition. What do we get? Plus dot, dot, dot. Because we're adding what? We're adding forever. Question, does this converge or diverge? Okay, when does it converge? It converges when the R value is less than 1. Or the absolute value of the R value is less than 1. Now, so we're looking at the R value is what? 2. So we say the absolute value of 2. Is the absolute value of 2 less than 1? No. The absolute value of 2 is not less than 1, so don't write this. That's false. Instead, write the complete opposite. What's the complete opposite of less than 1? We write what? Greater than or equal to 1 is the complete opposite. Is this true? Yes. Write only on your paper what is true. The absolute value of 2 is greater than or equal to 1, meaning that the series is divergent. This is covered in the last video. Now, divergent, why? Well, first off, our R value. Well, let's talk about what this means. Again, if the R value, look, if the R value is smaller than 1, Or maybe start here. If the R value is bigger than 1. If you're multiplying by a number that is bigger than 1, what is happening to each value? The values are getting what? Larger. And if the values are getting larger, as you continue to add, these are not getting close to a number. They're getting further away from any number you can think of. Think of a number, say a big number. How about 1,000? Someone said in class 1,000. Okay, is this getting close to 1,000? No. You may think it is, but it won't take long for this to get more than 1,000, or be larger than 1,000. In fact, 10 terms and you're more than 1,000. Okay, so after it passes 1,000, what's going to happen? It's going to continue to get what? Large. So we're not getting close to 1,000. After we pass 1,000, we're getting what? Further away from 1,000. So think of a bigger number, like 1,000,000. Will we eventually pass 1,000,000? Yes. And what's going to happen? We're going to just get further away. So what does this mean? Divergent means you're getting further away from any number you can ever think of. You say 1,000,000. Well, we're going to pass 1,000,000 and we're just going to keep going. We're going to get further away from 1,000,000. In fact, I think we pass 1,000,000 by the 25th term. It's not long before we pass 1,000,000 or 30th term. Now, up here, why is this convergent? Why is this getting close to a value? Because we're adding what? We're adding smaller and smaller and smaller and smaller and smaller values. When you add smaller and smaller and smaller and smaller values, the sum starts to get very close to a number, and this sum up here is getting very close to 16. We call this convergent. Why are the values getting smaller? Because you're multiplying by a number that is smaller than 1. Down here, you're multiplying by a number larger than 1. The values are getting bigger. Up here, you're multiplying by a number, 1/2, which is smaller than 1, causing each successive number to get smaller. Okay, so when you multiply by a number smaller than 1, the values get smaller. Now, this is not what you're going to see on your SOL, most likely. Most likely, you will just see this. So let's look. This is what you have to be prepared for. You're looking at this, 8, and this will be on the next quiz. 8 plus 4 plus 2 plus 1 plus 1/2 plus ... I tell students, okay, this is what you're going to be seeing on your SOL, and a lot of it. The SOL loves this question. So what do we do here? Well, you see the ... We're adding what? We're adding forever. So what do you first need to find? You need to know two things to figure out what this thing equals. A sub 1 over 1 minus r is the formula to figure out what this sum is. You need two things. You need a sub 1. Do we know a sub 1? Yes, a sub 1 is 8. Now, what else do we need to know? We need to know r. And how do we find r? Reminding you, we take what? The second value and divide the first. So we take 4 divided by 8. What do we end up with? 1/2. So our r value is 1/2, and our a sub 1 value is 8. So our formula is what? 8 over 1 minus 1/2. And we already know this from over there. 1 minus 1/2 is 1/2. We end up with 8 divided by 1/2, which is the same as 8 multiplied by what? The reciprocal, which is what? 8 multiplied by 2, which is 16. Now, sometimes the r value is not obvious. Again, even if it's obvious, you say, well, I can see I'm multiplying by 1/2. What do we do to find the r value? We take the second number, divide the first. But I tell students this, if there are fractions, it's actually easier. Let me show you some examples. First example is 8. Here, let's do this. 9 plus 3 plus 1 plus 1/3 plus 1/9 plus 1 over 27 plus ... When you see the ... you're adding what? You're adding forever, and you have to use the formula. The formula is what? A sub 1 over 1 minus r. Now, we need to know two things. We need to know our first value, which is what? First value, which is 9, and we need to know our r value. And how do we find r? We take what? The second number divide what? The first number. So we take 3 divided by what? 3 divided by 9 and reduce the fraction. 3 over 9 is what? 3 over 9 is 1/3. Now, so we have our r value, we have a sub 1, but I tell students this, if there are fractions, it's actually easy to look at your fractions and find your r value. What's being multiplied on top to go from 1 to 1 to 1? What's being multiplied to go from 1 to 1 to 1? Well, we say, look, if you just write r equals, what's being multiplied to go from 1 to 1 to 1? Well, 1 is being multiplied. On the bottom, what is being multiplied on the bottom? We go from 3 to 9 to 27. Well, 3 is being multiplied. If you look at your fractions, in fact, fractions make it very easy to find the r value. You look at what's being multiplied on top, what's being multiplied on the bottom. So we get an R value of a third regardless of whether you divide or you just look at your fractions. Now, our formula is what? Formula is a sub 1, which is 9. So we have 9 over what? 9 over 1 minus 1/3. Okay, 9 over 1 minus a third, which is the same as 9 over, what form of 1 do we want? We want what? 3 over 3, because we want a common denominator. Remember, 3 over 3 is an equivalent form of 1. Our denominator is 3. That does not change. Add the top. 3 minus 1 is 2. So we end up with 9 divided by 2/3 is the same as 9 multiplied by what? 9 multiplied by the reciprocal, which is 3/2. And again, this is 9 over 1 times 3 over 2. We take the 9 multiplied by the 3. We get 27 over 1 times 2 is 2. Convert this to a mixed number. 2 goes into 27 13 times with how many left over? 1. So we get 13.5. Now, let's look at this example. Question, is the R value obvious all the time? No. Look at this. 0.1 plus 0.01 plus 0.001 plus 0.0001 plus ... Okay, we're looking at this mess. A bunch of decimals. And what did I tell you to do? I said to find the R value, we take what? To find the R value, we take what? The second number and divide the first. So we're going to take 0.01 and divide by what? 0.1. Take the second number, divide what? The first. Now there's a trick here. If you get decimal over decimal, there's a trick here if you know this. Watch. What is 2.35 multiplied by 10? If we multiply 2.35 times 10. Okay, so if we multiply by 10, we move the decimal what? One place to the right. We make the value larger. Why? Because we have 1 0. You can multiply by 10, move the decimal, we get 23.5. Now my question is, what if we have 2.35 multiplied by 100? Okay, if we multiply by 100, how many times do we move the decimal place? Well, there are 2 zeros, so we're going to move the decimal place twice, making it larger to what? 235. What about 2.35 times 1,000? How many decimal places are we going to move it? We're going to move it 3 because we have 3 zeros. So we end up with what? 2,350. Okay, now, there's a way to get rid of these decimals. You have to ask yourself, okay, you can multiply a fraction by anything you want as long as you do it to the numerator and the denominator. Now, how many decimal places do we have to get rid of? The maximum number of decimal places that we have to get rid of? Well, 2, because there are 2 decimal places we have to account for on top. So what number do we have to multiply by to get rid of both decimal places in the numerator? Well, we have to multiply by at least 100. So let's multiply by 100. If we do this to the top, we do it to the bottom. Move each decimal 2 times. So we get what? We end up with 1 over, move the decimal twice, what do we end up with? We get 10, 1/10. And I want you to also notice, we want to make the values up here fractions. So my question is, what is 0.1 equal to? 0.1 is equal to 1/10. What is 0.01 equal to? 0.01 is equal to 1 over what? 100. 0.001 is equal to 1 over 1,000. You can hear it in the words. This is 1/10, 1 100th, and 1 1,000. Okay, so we want to convert this. What is 0.1? 0.1 is 1 over 100. I'm sorry. 0.1 is 1 over 10 plus 0.01 is 1 over 100 plus what? 1 over 1,000. And 4 decimal places is plus 1 over 10,000. Plus ... Okay, so we want a sub 1 to be in terms of a fraction. Now question here. Does your a sub 1 value match, right? A sub 1 here. Does it match your R value? Yes. So we have a sub 1 and R matching. Be careful here. This happens a lot. Okay, so we have a sub 1 over what? 1 minus R. I see this pop up many times. Same thing, though. You just put them in where they go. So we have a sub 1 is 1 over 10 over 1 subtract the R value, which is a 10th. All right, so we have 1/10 divided by 1 minus 1/10. And this is the same as what form of 1 do we need? Well, we need what? 10 over 10. Remember, what matches doesn't change, so we get 1 over 10 divided by what? Divided by, remember the 10 does not change. 10 minus 1 is 9, so we get 1 over 10 divided by 9/10, which is the same as 1 over 10 multiplied by what? Multiplied by the reciprocal, what? 10 over 9. And what happens? The 10s cancel, we're left with what? This is equal to 1/9. Now, I showed you guys something yesterday. What is here? Let's see what this is first. If we add decimals, let's start adding these up. the pattern. We have 0.1 plus 0.01 plus 0.0001 plus 0.00001, 0.00001, 0.00001. Okay, what happens when we add decimals? Well, we line them up, the decimals here, and we're looking at this pattern. What's this? 1 plus 0.00000, 1 plus 0 plus 0 plus 0 plus 0 plus 0 is 1. 1 plus all of these zeros is 1. 1 plus all of these zeros is 1. 1 plus all of these zeros is 1. And what? We get a 1, we get a 1. What is going to happen here? What is this thing equal to? This thing is equal to what? 0.1 repeating forever. And what did I tell you yesterday? In the last video, 1/9 is equal to what? 0.1 repeating forever. So you could have told me, if you knew that this was 0.1 repeating forever, the fact that you have 1/9 memorized, you know that this is 1/9. Now my question is here. Let's look at 0.3. 0.3 plus 0.03 plus 0.003 plus ... What do we have here? This is equal to what? 0.3 repeating forever, which is the same as what? 3 over 9, which is the same as, we reduce it, 1/3. You can be done without even using a formula. So it's nice to know that 1/9 is 0.1 repeating forever. All right, last one, last problem. So we're looking at here, 1 over 3, I'm sorry, negative 1/3 plus 1 over 9 minus 1 over 27 plus 1 over 81 minus ... Okay, so again, two things we have to find. We have to find a sub 1, and what is our a sub 1 value? A sub 1 is negative 1/3. The plus ... adding forever. We're going to use the formula that this thing is equal to a sub 1 over 1 minus r. And now, a sub 1 is negative 1/3. We have to find the r value. What did I say? Well, you can always take your second number and divide your first. You can always do this. So we have 1/9 divided by what? 1/9 divided by negative 1/3. This is not necessary, though. 1/9 divided by negative 1/3 is what? 1 over 9 multiplied by the reciprocal, negative 3 over 1. We end up with negative 3 over 9, which is what? Negative 3 over 9, which is negative 1/3. This is not necessary. Instead, just look. Just look. We can just look at what's being multiplied on top. What's being multiplied to get from 1 to 1 to 1 to 1? Well, that's a 1. And what's being multiplied on the bottom to get from 3 to 9 to 27 to 81? Well, that's a 3. So our r value is a 1/3. I told you if there's fractions, this is wrong, but if there's fractions, it's easy. 1 times 1 times 1, 3 times 3, 9 times 3, 27 times 3. You can just see the r value by looking at what's being multiplied on top, what's being multiplied on the bottom. Now, one other thing. This is alternating from what? Negative to positive, negative to positive. If it's alternating sign, then we're not multiplying by positive 1/3. We are multiplying by what? Negative 1/3. Now, what did I say? Many, many times, the SOL will throw you problems where your a sub 1 and your r value match. So be careful here. It doesn't really matter, though, where you put them. I guess it would maybe lead to less confusion. So negative 1/3 is our a sub 1. We have negative 1/3 over what? 1 minus, be careful here, 1 subtract what? Negative 1/3. What happens when we have subtract negative? This changes to what? This changes to addition. So let's change this to addition. So we have, let's see, 1 needs to be what? 1 needs to be what? 3 over 3? Okay, because we want a common denominator. We have negative 1/3 over 3 over 3 plus 1 over 3. The denominator does not change. We get 4 over 3. And negative 1/3 divided by 4/3 is the same as negative 1/3 multiplied by the what? Reciprocal, 3 over 4. And we cancel 3 with 3, and what are we left with? Negative 1/4 is the answer. And that concludes this video. So this is the last video on infinite geometric series. You have made